Dear students, in the previous video we defined orbital speed and we derived expression for orbital speed. Now let us do some problems on that. Two satellites are revolving round the earth at different heights. The ratio of their orbital speeds is 2:1. If one of them is at a height of 100 kilometers, what is the height of the other satellite? So here, first let us write expression for orbital speed. Right. Now this suggests you that G is a constant, M is a constant. That means VO is inversely proportional to square root of R plus H. So that you can write VO1 by VO2 is equal to inverse proportional. Therefore here 2 means 2 comes here. Here 1 means R plus H1 square root. So now the ratio of their orbital speeds is given 2:1. So this is equal to 2 by 1. Squaring on both sides. Or you can write 4 into R plus H1 is equal to 1 into R plus H2 and 4R plus 4H1 R plus H2. 3R is equal to H2 minus 4H1. So here the values H1 is given. H1 is equal to 100 kilometers and R is equal to, for Earth it is 6400 kilometers. So substituting these values, 3 into 6400 H2 minus 4 into 100, we get H2 is equal to a satellite is revolving round in a circular orbit with a speed of 8 km per second. Orbital speed is 8 km per second at a height where acceleration due to gravity is 8 meter per second. That means G of H is 8 meter per second square. How high is the satellite from Earth's surface? Height is asked. And radius of planet, that is capital R, is given. So H value is asked. We know that R plus H is nothing but radius of orbit. It is radius of orbit. Now while deriving expression for orbital speed, we started with, say, when this can describe a circle around a planet only when centripetal force is equal to gravitational force. Centripetal force is equal to gravitational force. That is, Fc is equal to gravitation. Fc means, suppose its mass is capital M, its mass is small m, then mv square by r is equal to g capital M small m by r square. R cancel, small m cancel. So this is equation 1. Now, while deriving expression for g at some height, how we followed? Gravitational force on gravitational force due to Newton's second law is equal to gravitational force due to universal law of gravitation. See, gravitational force due to Newton's second law, F is equal to mg. So here m is there, but it is some height. So here you write m g of h. Gravitation due to universal law of gravitation is g capital M small m by r square. M gets cancelled. So this is second equation. Now, first equation divided by second equation gives v0 square by g of h is equal to gm by r into r square by gm. Gets cancelled. Here r gets cancelled. So here let us write in terms of r. So writing in terms of r means, from this you have r is equal to v0 square by g of h. v0 value is 8 km per second, means 8,000 meters per second square by gh, 8. Here we get 8 into 10 power 6 meter, or 8,000 kilometer. 8,000 kilometer. Now, this orbit radius is nothing but sum of capital R and h. So capital R, small r is equal to h is equal to 8,000 kilometers. Capital R is given 6000 plus H is equal to 8000, gives H is equal to 8000 minus 6000 is equal to 2000 kilometers. This is the answer. Now look at the example 9.5. The planet Mars has two moons, Phobos and Deimos. 1. Phobos has a period of 7 hours 39 minutes. Here, see, around Sun, Earth is moving and Mars is also moving, and this Mars has two moons, two satellites. Start with out of the two moons, so one is Phobos, and it takes 7 hours 39 minutes of time to complete one revolution. That is called time period. So I have converted the time period into seconds here. Now, and an orbital radius of 9.4 10 power 3. Orbital radius is given 9.4 10 power 3 kilometers. If we convert this into meters, 1 kilometer means 10 power 3 meters. Calculate the mass of Mars. So, mass of Mars is equal to how much? That is asked. Since here we have time period, let us make use of Kepler's third law. According to Kepler's third law, T square is equal to 4 pi square by Gm into R cube. So here mass is asked. So 4 pi square by Gt square into R cube. Substituting the values, time period, R value, so simplifying this, we get, substituting the values, we get the mass of the Mars. Now second one. So what is asked in this? Assume that Earth and Mars move in circular orbits around the Sun, with the Martian orbit being 1.52 times the orbital radius of the Earth. See here, this is Earth orbit, this is Earth orbit, this is Martian orbit. So here the orbital radius of Mars is 1.52 times this value, that is given. So here what is given, let me write, given Rm is equal to 1.52 times Re, and What is the length of the Martian year? What is the length of the Martian year? That is time period, time period of Martian Mars is asked. So now again we make use of Kepler's third law. By T square, according to Kepler's third law, T square is directly proportional to R cube. That means R Tm by Te whole square is equal to Rm by Re cube. So this gives Tm square is equal to Rm by Re whole cube into this taken right side square. Earth takes 365 days to complete one revolution. Therefore here you write 365 days. Rm, see here it is given here. Rm value how much? 1.52 Re by Re cube. Rm value substituted here. Re cancel. Tm square. So here we get now Tm is equal to now example 9.6 weighing the earth. You are given the following data. G is equal to 9.81 meter per second square. Re radius of earth. The distance to the moon. And the time period of the moon's revolution. Obtain the mass of the earth in two different ways. So one method is relation between small g and capital G, or let us write on surface of earth. See, let us write like this: on surface of earth. Suppose there is a body of mass m. This is the mass of Earth. It's okay. So on surface of Earth we write mg is equal to g capital M small m by r square. This is according to Newton's second law, and this is according to universal law of gravitation. From this we can find me. This is me. me is equal to g into re square by capital G. G value 9.8 on surface of Earth. Re value 6.37 into 10 power 6 by G value 6.67 into minus 11. Now let us follow another method, that is Kepler's third law, that is law of periods. According to the law of periods, T square is equal to 4 pi square by Gm into R cube. So here time period of moon, say moon is revolving around Earth, therefore is there moon. Here m. Actually let us write like this. It is written for Earth Moon system. Let us write the formula. Tm square is equal to 4 pi square by G. This is Earth. Rm cube. Now we should substitute the values. First me. From this me is equal to 4 pi square by G Tm square into Rm cube. So in this substituting the values, Tm square. See here Tm value Tm 27.3 days. 27.3 into 1 day means 86,400 seconds. Into Rm value 3.84 into 10 power 8 cube. So substituting these values we get so in method 1 and in method 2 the values are almost same.